Section 5.2, a huge topic on the AP exam, yes or no?
No.
No, which is why our test on Monday, on Chapel Day Monday. Oh my goodness, because this is not only this week, it's also next week. Our test is only going to really be on 5.1 and 5.3. Okay, because that's what's key for the AP, and that's why I'm able to have it in a shorter class period. It's a shorter test on just 2 sections. But we have today to finish up 5.2 questions, because I just wanted us to touch on it fast. And then we can get into 5.3 and hopefully have that mostly covered as far as the big ideas, so that on Friday we can have a work day and kind of figure out what's working, what's not, be reviewing, be asking questions, etc. about the big ideas. But, okay, camping out in 5.2 for a little bit longer. Guys, from pre-cal, when it says is proportional to, from pre-cal and math modeling, is proportional to, means, is implying direct proportionality. And direct proportionality from pre-cal, in regards to inverse proportionality, says something is directly proportional to something else versus something is inversely proportional to something else. Common math language, I know it might not be common to you, but common as far as like relationships of data, or I should say of variables. So when they were saying is proportional to n, they were saying it's k times n. And from section 5.2, not that we're going to memorize it, we're not going to be like a physics class, we're not going to be like a chemistry class where it's just like, whatever, math happens, and then boom. We're not going to be memorizing this for the AP, but we are playing with it. We are kind of, in a sense, using it in this section. There's a lot of math that happens right here. And I'm really sad because for some reason I thought I was going to do that math, and now I don't think I am. But I had all the math of where that came from on the board when you came in this morning from someone's question yesterday. Maybe as you guys play with the pre-cal in just 1 second, I'll do a quick little like, how does that happen? But what we saw yesterday was exponential growth and decay. Whenever you have the rate directly proportional to the amount, not to time. We're used to time being over here, like x being over here. We're not used to y being over here, or n being over here. But if I have it directly proportional to how many? So the lower my numbers go, the slower the growth. The higher my numbers go, the higher the growth. That's what's going on. Which is why it kind of has to do with like decaying away or population booms, in the sense of the more people you have, the faster reproduction will happen, etc. As long as, well, let's not go into that. But anyway, exponential growth or exponential decay. The higher the numbers, the higher the growth, the faster the growth. The lower the numbers, the lower the growth. If you have this special relationship, exponential growth or decay will result, and that's this guy right here. The how we'll answer in a little bit. So if you have that equation, I mean, good old-fashioned pre-cal, I mean, can't we go ahead and plug in stuff and say it's just good old-fashioned, there's an x and there's a y, and we plug it in. Except the x is a t and the y is an n, so I can go ahead and throw in stuff like, hold on, that's our objective for later, but for right now, plug in what you got. Use your clues. This is good old-fashioned. Plug it in, plug it in. Is that going to be able to get me something? Heck yeah, it is. And then if I come down here and if I say 400 is how many I have when t is, I believe with this one pretty fast, anything to the 0 power is what, guys? C is just equal to 350. So now all of a sudden I can say 400 is equal to 350 times e to the 1k. Somewhere in homework, I think it asks for a percentage, doesn't it? Somewhere in homework it asks for a percentage. The way it can be asking for a percentage is if you divide what you currently have from what you had before, 400 divided by 350. Now try to keep things exact. I saw someone's homework this morning where they had rounded and that web assign was not a fan. But this would be, if I was to estimate it with a decimal, this would be the same thing as 114.29% growth. You can divide what you have from where you started and you'll know how much growth you had. Or I should say, we are at 114.29% of what we were to begin with. That means there was a growth of 14.29%. We can find percentages if we need to. That's not the point of this question. That's just helping you in maybe a future question. But the long story short of it is, can you find k? And the answer is yes, I can find k. I can take ln. Once that's gone, I can take ln of e. I know k is equal to 40 over 35 because the 0 is reduced. That'd be 8/7, right? So how do I find n of 4? I take all the information, I take all that I have, and I say n of 4 is my snazzy equation from back here, but I know the c. The c is 350. I know the e. Now I know the k. Ooh, where'd my ln go? My bad. ln of 8/7. Careful. What comes next is not in the ln. K times t, and t is, like they told me, 4. All you gotta do is plug and chug, cool kids. All you gotta do is plug and chug. As you guys are plugging and chugging and getting that locked into WebAssign, if you didn't have that in WebAssign before, just so that we have it somewhere, the how as to how this happens. We would do the calculus that is going to be required in section 5.3 when not every differential equation is this basic to where it returns to this very common type of growth in nature. To do the math, we would have had to have actually multiplied the dt on the other side. We would have had dn is equal to, we would have moved that dt like you see in your forever card. Separate the variables. The n does not belong. K is just a constant, so I divide that n to the other side. This is what we're going to be working on in 5.3. But if I rearrange everything to where all the n's are with the dn can't be divided. It needs to be up top, which is why I always multiply up that differential. Then I have this little ln of n equals kt plus c. It's like, oh, plus c, I'm used to that guy. And it's like, yeah, I know, but if I'm getting n by itself, if I'm getting the y by itself or the n by itself, I would need an e. And algebraically, if I have e to a power, that's the same thing as I have kt e's and another c e's that are being multiplied. Algebra says I have KTEs, and that plus C means I have C more E's that are being multiplied. If you were doing this in a WebAssign, it might have had like a C1 and a C2, and this might have been a C3 once I move it all over. And E to the C3 would have gone ahead and been able to be rewritten as a CE to the KT. That absolute value kind of gets absorbed into like a plus or minus. Could be. But that's what section 5.3 is about. This is not what section 5.2 is about. So we'll be coming back to stuff like this. This is just the behind the scenes, the calculus that most kids don't even think about whenever they have radioactive decay or whenever they have bacteria growth or whenever they have population booms or continuously compounding interest. They just use this special type of growth or decay formula and don't realize there's this whole calculus thing behind it. So don't stress about that. At the end of the day, you guys should get those green check marks. Is it working? Cool. That was for number 6. For number 8, it's actually super similar because do you guys see it's an exponential curve? It's just an e that's been like reflected, right? So with that e that's been reflected, I'm going to go ahead and move this. TBH, we don't need this. Making room. That 114% was just extra because I think a percentage thing comes into play somewhere. So just reminding you that this little ratio tells us like the percentage of how fast it grew or how much it grew. But for this problem, all you needed to do was then take it all and plug it in and say equals and find that equals. But over here, the nice thing is you have the exact same thing. So it's actually still just pre-calc. So I can look at it and say, oh, that looks exponential. And if it looks exponential, I'm like, okay, CE to the KT. If you want, you can make it CE to the KX, but T is pretty normal in these problems, so that's why I'm using that variation. I just plug in stuff just like I did before. So I plug in y is equal to 7 when x is equal to, and I'm pretty sure you're going to find your C real fast. Then you're going to plug in the other point, which says 1/2 Ooh, this is decaying. Oh yeah, obviously it's going down. CE to the K times 8. And do you guys notice it's the exact same thing as over here? It's the exact same thing, just no words. No steps. It's the exact same thing. So go ahead and do your math and do your solving and you'll get what you need. You're going to get that guy to be 1. You're going to have C is equal to 7. You can make a quick substitution if you know what that word means. Think an Algebra 1 teacher. You can plug in that 7. You can solve. You'll end up with what does K equal, hopefully with an ln somewhere in there. And someone can check on number 8, but I think on number 8, all they wanted was the equation. Isn't that right? So all I got to do is plug in your C and your E and your K and then your T, boop, boop, and then you'll have your final answer. So 6 and 8, very similar, plugging into my exponential growth here, decay here, but it works the same way. Just this K, if you plug it into your calculator, would have been a positive number showing growth, and this K over here would be a negative number. And number 11, things get a little bit more interesting because they put some words to it and talk about bacteria. But if you guys notice, they're giving you clues again. They tell you after 2 hours, I have 135, and after 4 hours, I have 425. The bummer is they don't give me at 0. The other ones they give me at 0. This one they don't give me at 0. The other ones they give me at 0. This one they don't. But that's okay. I can still plug 2 points in. That's the thing. P.S. Remember, if you don't need this, go to 5-3. I bet you can start your homework. We're going to ask your perspective on it in just a little bit. So if they want the initial population, for us guys, that's going to be the same thing as y of 0. Or if you want number of bacteria, you can call it n. N of 0. It's probably going to be C. But still, just do your pre-cal. Oh, they call it y. I just noticed they call it y down here. You can call it y, that's fine. Y of 0. But do your pre-cal. It says that the bacteria is increasing by exponential growth, so I can go ahead and do my y equals CE to the KT, which K times 2, 2K looks nicer. 425 is equal to CE to the 4K. Now the big bummer is I don't have anything making the power 0 and making the E go away. But that doesn't mean that I am powerless. If you guys notice, think about good old-fashioned algebra. Can't I solve both of these for C's and set them equal to each other? With some pretty quick pre-cal thinking, aka no derivatives, no integrals, just playing with equations, I can say that 135 all over e to the 2k is equal to 425 all over e to the 4k. You guys agree? Just good old-fashioned math. I'm just playing with equations. This is the same situation with the same C, the same initial population, the same bacteria population, or growth. So I'm just solving for C by division, setting the two equal to each other. Maybe some cross multiplication would be great, and pretty soon I would get e to the 4k over e to the 2k is equal to 425 over 135. The really cool thing about that is I can just subtract those exponents, so e to the 2k is equal to... Is this the one you were doing this morning, Lucas? I think it is, right? The 425 over 135. That can reduce as a fraction. You know what? Hold on. Calculator skills. You know what? Calculator skills. I was going to do it in mine, and I can real fast, but I'm going to show calculator skills. Calculator skills, I can do that 425 divided by 135. It's a decimal. They don't want decimals. They don't say about rounding, at least not yet. But remember, alpha, y equals, change a fraction to a decimal to a fraction. As long as you're doing it right there in the moment, If there is a fraction, it should normally get it for you. 85 over 27 is going to be this fraction. Just to save you some time and mental energy, taking an ln of both sides, and then k is going to equal 1/2 ln of 85 over 27. Since this argument is bigger than 1, that's going to be a positive number showing the growth. The 1/2 is a square root, but it'll still be a positive number. It's growing like I want it to be growing, but they want the initial population. Ugh.
Where did your e to the 4 come from?
Oh, buddy, remember when I'm dividing like bases? I subtract the exponents. Yeah. So 4k minus 2k was 2k. Good question. Then ln of both sides, and then I just divided by 2. And so with that k, I can totally find my c, because my c, or my initial, says, okay, well, what's y of 0? Actually, I had it back here, I think. Because I can just plug in, like, go back substitute. Ooh, that's a good thing from last year. I can back substitute, take this k into one of these equations, and then say, okay, so c is equal to, which is the initial in all these situations, e to the 2 times 1/2 ln of 85 over 27. And the nice thing is, now careful. Ooh, someone asked me this yesterday, careful. No crossing off e's and ln's until I do reducing or making powers of whatever's in front. You gotta get that ln right up next to that e to simplify. But if I reduce 2 times 1/2, it's really nice. That goes away. E and ln can then go away. And then I end up with 27 times 135 all over 85. And you guys can simplify and get that right there. I think they went the fraction, if I remember right from Lucas. Oh no, nearest whole number. Never mind. Nearest whole number, so don't forget to do that. Right, an exponential growth model. Well, guys, as soon as you find the c, you're going to be plugging that into the c right before your e to the k, which you already know, which is 1/2 ln 85 over 27. T. Then it says, after 8 hours, no stress, I just want y of 8. Plug it in. You guys notice it's a lot of like mathematical modeling, kind of pre-calc stuff. After how many hours will the bacteria count be? We're not plugging in t anymore, guys, right? What's 20,000? It's not a t.
Is that what it equals?
That's what it equals, yeah. So it would be 20,000 is equal to, well, whatever that c is, e to the whatever your k is. You gotta solve for t. I think you should be okay in the ones up as far as like plugging into your calculator, rounding to the nearest whole number, putting that into the c spot, and then rewrite or finishing your equation. Plugging 8 into that equation in your calculator, sweet, round to the nearest whole number. But at this bottom one, when it says to solve, I don't know what that number is. Just real quick as far as the math, I'm a little bit scared about you guys in the math. We would divide by whatever that c is. And just a few of you would do some kind of illegal simplifying, so my advice, would be kind of twofold, but here's where I'm scared, so let me go ahead and just show you. Not scared as in terrified, but scared as in, like I've seen many, this is the sad part of being a teacher, many kids before you make these mistakes, and so trying to call you out, trying to call your attention to it, trying to warn. This 1/2 in front, I cannot, no. That's killing something, I just haven't made an animal for it. But I can't simplify the e and ln because of the 1/2. 1/2 times in an exponent is different than 1/2 times anywhere else. It's in an exponent, it has a special exponent meaning. The easiest way to avoid error is to put that 1/2 where it belongs. And where that 1/2 belongs, because it's in an exponent and because it's with the ln, would be right here with e to the ln of the square root of 85/27 times t. If you process the 1/2 and get the e and ln, then you can simplify. But you notice it doesn't end up to be 1/2 times, it ends to be square root, which is drastically different. So that would lead us to what t is equal to? 20,000 divided by whatever you get your c to be. Probably should have made it a variable. I guess I could have made it a variable, but I wanted you guys to plug it in. Divided by the square root of 85/27, which will be the same thing as times the square root of 27/85. Then you guys will have it. But am I just doing a lot of pre-cal up here? The answer is yes. I'm plugging in and I'm solving. I'm plugging in a time. I'm plugging in some points. I'm plugging in a population. This section was not to stress about the calculus. This section was just to read and to play with the math. Yeah.
For part B, how are we supposed to plug it in? Because like I've tried it 2 times and it says wrong.
Oh, you know what, Lucas? Is this the one where you round it, but they don't want the rounded? Is that right?
Yeah.
Okay. No. Thank you. Thanks, Josh. You round it here. Does somebody have that answer for me then, real fast? The rounded one, is it 43?
Yeah.
So the rounded one ends up being 43. But they don't want 43 here. They want the simplified fraction, which would be here. Calculator skills. It's this nasty fraction, right? So 27 times 135. Thanks, Josh. It's that idea of them trying to avoid error, so they don't want rounding upon rounding upon rounding, but they don't say it very clearly. So then you would want to do alpha y equals fraction 729/17.
Okay, yeah. Thank you.
No, thank you, because I would have just been like, yeah, guys, it's easy. But it wasn't. 729/17. They don't want the 43 version, they want that version. So then use this version for the rest. So this will be 729/17. But remember, calculator skills. You can throw in this messy expression, right? You can do your alpha y equals and get a fraction. You can do your 21, 2, 3 all over. You can do another fraction down there. That's the great thing about the updated operating system of your graph, where you don't have to worry about nasty parentheses and stuff. You can just go ahead and throw it all in, get what you need it to be. You can even do like times 1/, or divided by, but I just know how this works in the sense of you multiply by the reciprocal, right? You can do your 27 over, oh, lame sauce. Hey, what's that calculator shortcut key? I want to get all the way to the end without scrolling through everything. Second over, nice, and then just go back. I can do my 27/85. Feel free to double check me, make sure you guys are getting those green check marks and WebAssign, but you were rounding to 2 decimal places. Yeah.
On the calculator, how do you get it to a fraction?
Oh, it's this thing that I keep on using, alpha y equals enter. So alpha y equals. There's these F1s, F2s, F3s are hidden menus.
Is that will get you 729/17?
Mm-hmm. Well, I did an alpha y equals, and when I was in the denominator, I did another alpha y equals.
So I'm talking about the one above that where it says answer X, answer D.
Oh, same menu. Sorry, but number 4. Yeah, and it's the same thing as math, like telling it which one. Just the cool thing is that this one up here says I'll take it to the other, whatever the other is. So it's just a shortcut. It's kind of nice. Yeah, good question. Okay, that was number 11, and then number 12. I believe is super similar, just it's not bacteria. Bless you, it's money, right? Except the nice thing is, what do they give you in this one, guys? I think they give you the equation. They tell you the beginning clue that 0 doesn't mean like the year 0 when Jesus was born, but instead, right, it was the year 2010. They tell us that the money earns interest continuously at 10%. And that gives me the present value of the timber. So careful, there are a couple different things going on, and that's where we have to be dicey, where we have to be careful. Wrong word. Because the value of a tract of timber and then this other one is the present value of the timber at any time. Present value. So I think this is the land as you guys keep reading. The tract of timber, tract of land. I believe that's the tract of land. And then this one is taking into account the present value of the timber, which is related to the tract of land. And it wants you to maximize the present value function. Now, as we check out this one, it might be easier if I just go into the question itself. They do try to lead you through step by step. It isn't something where you have to come up with everything on your own. For instance, they give you this equation that they told you. They say like, hey, remember, V is equal to this. So if we plug that into that, what would we end up getting? So you just plug in, plug in, plug in. Keep writing. Got it, got it, got it. And then you're simplifying stuff a bit in the sense that you have an e to the and another e to the. So then they're joining those two e to the. So Andy, here's another one of those like base things. We have like bases. I know that's high and that's low. It's just because of the awkward WebAssign box, but they're being multiplied. So we just add their exponents. So it'd be 0.6 square root of t minus 0.1 times t. So you're just putting those exponents together because they're both e's. I can mush them all together. And for you guys to realize this is all the exponent of e. They just made it look kind of gross. But then they have you remember that to maximize stuff, critical numbers, I need to take a derivative. Critical numbers, they have you say that the derivative of 105,000 e to the u is 105,000 e to the u times u prime. And you're just writing, let's take the derivative for u prime. Let's take the derivative of, you're just rewriting it. Then you're actually taking the derivative, bringing down the 1/2 power, making it a negative 1/2 power, minus derivative of anything times an x or a t is just that constant, the constant multiple rule. You're finding a crit, and to find a crit, you set this guy equal to 0. E can never be 0. 105,000 can never be 0. So they're moving that guy to the other side. They have you split up and say, hey, I have factors equal to 0. Either that guy's 0 or that guy's 0. You can actually, well, no, you guys can't see this until later. You could work your way backwards if you could see it. But they're saying, E, remember, horizontal asymptote, he never hits. ln of 0 doesn't exist. That won't ever happen. So I have to look at this guy. So I add, I multiply, I divide, I square both sides, and I end up with 9. If you want to write down that number, you end up with 9 as your critical number. And then basically it just says for you to use it and say, sweet, 9 is the place of the critical number, and it's that whole assumption of it's going to be the max if I make my sign chart. And that would be the year 2019. But I can go back wherever you want if you don't know how to plug in stuff because of the weird WebAssign writing. Josh, do you need me to go back to a box?
Can I ask about 11?
Let's double check before I go down to 12. Is anybody currently in 12 trying to make things match? One of the boxes is weird. I can go wherever you want. Step what?
No, I'm just going to ask, why is it the like base thing?
Say it one more time.
Why is it the like base thing?
Up here. They wrote it weird. Let me come over here real quick. Remember WebAssign, like, sometimes it's kind of wonky when they put it in? So check it. This is a little weird. What they're saying is A of t is equal to 105,000. It was E, and all of this was in the X. This is where it got wonky. All of that was up there.
Oh, I didn't see that.
I know, right? Because the spacing is weird. So then now it's like bases. So I could just say 105,000 e to the 0.6 minus 0.10. Actually, it's not bad if I write it here. I think that'll make it easier for you guys. then we have to go looking for crits, and so to go looking for crits, for that whole maximizing idea, we would want A prime, which would be 105,000 e to the u times u prime. I think WebAssign has you kind of put that in where this is my u. And so that's where you end up with 105,000 e to the 0.6 square root of t minus 0.10 t times 0.6 over 2 square root of t, which they reduce that to be 0.3 minus. And then they say, you want that to be crits? Set that guy equal to 0. If I divide by, this ends up being 0. And so I land at either e to the which ln of 0 doesn't work, so it's impossible. Which they have you say is something about not a valid solution. Or the other ones, remember we're looking at both of our factors. See, where this one equals 0 or this one equals 0. In Algebra 1, I would say splitting the red C, you're setting each factor equal to 0, splitting them up. I know I'm helping a lot, but I also know this isn't a huge reading problems. Understanding what they're saying. Knowing when to plug in times, when to plug in amounts, knowing when to take derivatives. That's all good. So actually this is a kind of nice problem in that way. But the rest of homework was a lot of just pre-cal, so I just wanted to go through as much of it as I could with you guys. This one, though, you can totally solve. And you end up with t equals 9. After adding and multiplying and then dividing and then squaring both sides, you should end up with 9, which would be 2019. Does that help, Andy, having that in the Jamboard?
Yeah.
Cool. And then Josh, you wanted me to go, so for everybody else, that's in the Jamboard too to help you guys out. But for Josh, number 12, what do you want to see in that one, kid?
For number 11.
Oh, number 11, thank you.
So, I followed the steps for the last one, but I didn't get that.
You didn't get 10.72? Let me double check. Ooh.
Because, like, A, B, and C are right, but I think it's probably just a step B.
Yeah, I must have just done something funny. So we're setting this whole thing equal to 20,000. I didn't put in the wrong number. 20,000. Yeah, 20,000. Divide by my C, which is 729 over 17.
Does the 1/2 affect the T? Or no?
My K was 1/2 ln of 87. No, because the 1/2 could have been brought up here. You see it? And so to the 1/2 power is where that little square root guy comes from. Oh, I made an algebra mistake. We should sue. It's not algebra. It's exponentials and logs. It's whatever. Transcendental functions. It doesn't affect, the square root doesn't affect, but check it. What does affect? This would have needed to have been e to the ln. The t had an e base 2. Actually, not even that. Hold on. That wouldn't be a times, because that would be a plus. It's actually, it would be, mathematically speaking, it would be that. Because a power to a power, you multiply. So, it would probably be way easier. So I could undo the e to the ln, but then I have the square root of 85 over 27 to the t. Like, how do I get rid of that? It probably would have been way easier if we had just taken ln of both sides way back here. I tried to get rid of it, but I didn't realize that t wasn't attached. That was my own incorrect assumption. So even though I made it pretty to where the e and the ln are next to each other, I technically have this separate from that. The t is not in the ln. It came later. So then what I should have done instead is the good old-fashioned pre-cal of I should have taken ln of e, ln of this guy, which would have been here. Then I could have divided by. Because once the e is gone, the ln is just something being multiplied. Then I could divide by, aka multiplying by 1 over ln of. So that was my mistake. The 85 over 27 was inside an ln. That t made it to where I couldn't just cancel those out. It wasn't just the e and ln. It was a more complicated power. Then that should work out pretty nice. So ln of 1, 2, 3. Jesus loves me. 1, 2. Jesus loves me. Times 1.
Is the answer like 6?
I think it was like 32. Oh, 10.72. Sorry. There it is. There it is. Okay. Let's go ahead and take a 3-minute break. Sound good? Get some coffee, stand up, get a donut hole, stick your head in the hallway. And then we're going to go to 5.3. But some of you guys need to detach your retinas from numbers for just a second, because we did a lot of pre-cal. Pretty advanced pre-cal with e's and ln's and plugging and chugging. I'll pause the recording. For those of you guys just joining us in the video, they're still kind of finishing up their break. I'm just going to solve this little guy that's been waiting for us since they started notes a little earlier on. And then we'll talk about any questions they have before we move on. Did you guys watch Blue's Clues when you were kids? Have I already asked this? Or have we moved past that generation? Is that generation gone?
I watched it.
A couple of you, I think.
I don't know what it is. All I heard is that. It was like, that's it. It's the pussies under the.
Make it as easy as possible.
Hey Josh, those chocolate cakes are good. You got it right.
Big, but you can't do it. No, trust me.
The chocolate things are pretty good.
Thank you, sir. Such a truck. That's a little bit. Goes and then. It should be fun. Those boards.
He's gonna knock my heart. You just gotta get it.
So you can do that. I don't know what's going on anymore.
School stairs.
What? We switch places. And then if you did, I got started and you're like, no. I didn't see you. I got that. No, I haven't opened it. No, I didn't.
Alright guys, we gotta transition. We gotta transition to 5-3. So as we transition to 5-3, I think a lot of you got a lot of good 5-2. I think homework help done. Web assign, some stuff done, or at least get jam boards that you know will lead you all the way. What I want to do right now is just, I'm going to pause the recording. Actually, I can keep it going. I'm just going to be available as you work through what I solved. As you work through what I solved. I'm just curious. Ask questions. What does or doesn't make sense? What can you verbalize about the steps that I was doing? What can you verbalize about the steps that I'm doing? I am doing, I was doing. Maybe you're thinking of your forever card behind the scenes, which has something called solving by separation, aka solving a differential equation, aka trying to go back from a derivative to original. I love you guys, but you gotta transition. Because this is the point, this is the calculus. This is where we gotta go. I will be available. All day. Until I'm sneaking in to watch some of the videos. Go back to studies, that's the video. Oh, because it was part of power rule. Y squared over 2 that I should put on top. What did I do up here?
Oh my gosh.
That was cool.
I know.
Separation. Oh, actually.
Separation, right? Didn't I multiply by dx on both sides?
That you did.
Right? So I multiplied by dx on both sides. I want you guys just to focus on the math. I multiplied by dx on both sides. But what does not belong over here?
The Y.
Because I need everything to be in terms of x as established by me multiplying, right? Now I'm going to want to do this integral. I want to do that, but I can only do that if I have function in terms of y with dy and function in terms of x with dx. Does that make sense? Your forever card, didn't I show the same thing? Anything with y's needs to get moved. Anything with x's gets to stay. Anything with the dx needs to be moved. The dy gets to stay. Now, a question was posed to me. Where did the 1/2 come from? Power rule, because it was y. I need y squared over 2. I just wrote it by 1/2 to avoid like a weird, I don't know, quotient thing. But y squared over 2 or 1/2 y squared, 1/2 x squared. Now is this necessary, the yellow stuff, is this necessary to show every single time? No, because what's going to happen every single time? I'm going to get just a big old-fashioned plus C at the end. But I'm just showing you, like WebAssign did in a problem or two. Technically that has a plus C, technically that has a plus C. They join together to be a new plus C, but the main one is this last one, right? Here's our arbitrary constant of integration. Now, you can do a couple things. I went ahead and went straight for the clue from this. I went straight for the clue from that. And you see me doing the clue right over here, taking my point, plugging it in. Right? I plugged in 0 for the x and 4 for the y. So yeah, that might be a good thing for me to mark down, just kind of basic algebra. Remember that y of 0 equals 4 is like f of 0 equals 4, which is like 0, comma 4. Remember? I'm trying to zoom, but I have too many things in my slides, so it's not letting me zoom. But that's okay. So yeah, I have my x and I have my y. Plugged in my x, plugged in my y. Someone else is using that timer. But once I got my c, that would go into this c spot, right? I still wanted to get y by itself. So to get y by itself, I went ahead and, with my new plus c of an 8 that I could have plugged in, I was just saving on space there at the very end. I multiplied both sides by 2 to get rid of that 1/2. I distributed 5 over 4 times 2 is 5 over 2. My 8 times 2 ended up being 16, and last but not least, I just needed a plus or minus square root to get rid of my square. True? This is basically 5.3. But calculus is going to get more interesting. Guys, was this a CE to the XT? No. But it was technically something else that could have come out of a different type of rate equation than section 5.2, and I just had to do some calculus to figure out what it is. The C ends up as a weird, like, stuck under a square root thing. The more complicated or the more involved the differential equation, the more the C is going to maybe move around, change places, and not just always be this added guy on the outside, because when I get y by itself, it kind of gets trapped, and that's okay. That's just part of the math. Do you have a question, Vic?
Oh, I could have just, or you could have just multiplied the 2 y, like, at the beginning.
Yeah. So I mean, I don't know exactly why. I just kind of went straight for the C, then plugged it in, then got y by itself. But you could have done the reverse order, gotten y by itself, plugged in the 0 and 4. 4 equals, you would have squared both sides, 16. That would have been 0, so C would have equaled 16. Yeah. So what if I was to give you this guy? Ready, set. The question is, can you separate? Ready, set, and the question is, can you separate? You have to separate first. You see the goal is to solve. There is no clue, so this is understood to be solving for the general solution or the particular. There's no clue. General. Good. Can you separate? And then to solve, then we'll integrate. P.S. Double check your work. Have you yet rewritten y prime as dy dx? Have you yet rewritten y prime as dy dx? You're trying to get a y equals at the very end. Is that right towards the beginning? Have you separated it legally? Have you separated it legally? Now, careful. Hopefully you guys would know the integral of 1 over y is ln of y. But how many of you are jumping to 3 ln of 2 plus x while completely and utterly ignoring what we did for an entire chapter called u sub? Would you have been okay this time by making that jump? Yeah. Why is Hogan saying yeah? Because what's the derivative of 3 ln of u? Isn't it 3 times 1 over u times u prime? And what is the u prime? Just 1. So you would have been okay, but what did I say? This time. There's one in homework that had a negative and you needed the negative in front or else it would have all gotten messed up. If you totally ignore the u sub, I'm just letting you know they write multiple choice questions on purpose such that your brain would make the jump and be wrong, and they write that as a multiple choice answer. If there was a 4 right there, we would have needed a 1/4 or else you would have gotten it wrong. You gotta do your u sub. Lucky for you, the du or the u prime on this one is 1, but that's not always the case. And I need to rewrite this question so it's not the case. But if you can rewrite it as a 1 over u, then yes, you can make that jump. Now hold on. I know that my problem said solve for y, and that is sometimes what you need, but some of these are going to be really messy, and if they're really messy, they might not always want y to be by itself. Lucas Fletcher had gotten into 5.3 during the time that we were working on 5.2, and he said, hey, look. These first problems, they don't want y by itself. Instead, what they want in the first few problems of homework is actually c by itself. Well, that's weird. Why would they want? I don't know, but it's another way of writing it. They're not wrong. They just, if they don't say solve for y, you might just be getting it and then leaving it. Or getting it in what we would call standard form. And standard form would say, like a standard form of a line, ax plus by is equal to c. Like, it's really similar to that. They're doing that, it's just way more complicated than a line. Or standard form of a conic section. That was with the A's and the B's and the C's equal to whatever. So you could say C equals, to be honest, Lucas, if you don't mind, I would much rather have the C at the end, like a linear equation. And so then we would have, if we were writing it a different way, it'd be ln of absolute value of y plus, no, just kidding, minus 3 ln of 2 plus x, which is good and all, but technically I wouldn't say you should stop there. Because you could also go ahead and put that up and do a quick little ln of y over 2 plus x cubed equals c. We could rewrite this a lot of different ways, but what if we wanted the y by itself? If we wanted the y by itself, we would then need to go ahead and bring in some of our pre-cal skills like we did last section, which it was helping us with that, hopefully. However, some of you would make a grave error right here. If you were to write this in its simplest form, the absolute value kind of gets absorbed. As we talked about before, we can make this an e to the, an addition of powers means there's been additional e's. Remember, we could make this some sort of like, what, C1, C2, C3, and then we could make this into like its own arbitrary constant, so I can make all of this into like a big old fat constant of integration. That constant of integration kind of absorbs the plus or minus from the absolute value, so I get y equals c, but do you realize that I would end with 2 plus x cubed? Where the heck did my e and ln go? These are two different variations of writing the solutions. One if they want y by itself, one if they don't care and you can get c by itself. It could be this or it could be that. And this is where homework starts. Homework starts by saying, it's okay, it's messy, I get it, just get c by itself. But where did the e and ln go? Anybody notice? What happened to the 3? It went up as a power, and as soon as it got out of there, what did the e and ln do to each other? Got 'em.
How come the e to the c just becomes a c?
Oh, because e is a number, 2.71828 raised to any constant will be a new, like a C4. It'll be a new constant. So like how the C1 and the C2 became a new arbitrary constant, it's the exact same thing. And this one though, the addition in the power meant there was additional e's being multiplied. Remember, that's what this notation means. It's a like base, those are added. So when I take them apart, I have a multiplication of more c's. So e to some constant, a number to some number is a new number. Yeah. And that's what calculus was behind the scenes in section 5.2 that I kind of showed really quick, like the how. Like it happened here also. But we just didn't have to do the calculus in 5.2. We were just trying to work with the pre-cal.
In the homework, there was one where it was e to the negative x squared over 2 minus c, and then you just brought the c down. So how come that in there it's like time?
Hovan's jumping us into like a step of a problem. And it was e to the x squared over 2 what?
Negative x squared over 2 minus. And then you just got the minus c and put it in the front.
Because this would be e to the negative x squared over 2 times e to the negative c, which could have also been rewritten as e to the negative x squared over 2 divided by e to the c, or times 1 over e to the c, but 1 over a number is still a number. Does that make sense? Yeah, 1 over a number is still a number. So it's okay. I wouldn't even have necessarily have made it a negative. I probably would have just made it a positive, but then depending on your clue might have said I needed a negative number there when you solved. Yeah, the plus or minus is like, okay, I don't know what it is until I plug in a clue. And depending on how complicated the slope, like if the slope field is one of those like it's basic, it's all the same, anywhere you are in the family of antiderivatives, then it would just be one number, a positive or a negative. But if like it behaves differently in other ways, you might have a positive in one place and negative in another place. But when you plug in the clue, you'll find that. Does that make sense?
Yeah, good.
Okay. Guys, if you check out the slides, I know we only have 5 minutes left, but can you look up here real fast? This isn't specifically a homework help. I was just going to get us into a free response, an AP FRQ, and then another AP FRQ. And then I was going to be like, okay, cool, like we're ready. Like I could say right now, we're kind of ready to tackle homework. But instead of us going to FRQs at the end, some of you guys did get into section 5.3, homework. Does anybody have a problem they're currently on? Doesn't even have to be the hardest of them all. But you're like, sure, let's go for it. Lucas, what do you got? Number 6. So I'm going to go grab number 6. If you guys want, you can go ahead and do WebAssign or homework 5.3, number 6. Let me go grab it real fast. And we're just going to end on this example, one of your homework problems. Sound good? And then on Friday, in the midst of our review, we might just start off with an FRQ or something. If you guys realize there aren't really forever cards for this chapter, it's just one. And I'm not going to have a forever quiz per se, because it's more of an understanding of how to do problems. You guys can once again use your forevers. 6, right, Lucas?
Yeah.
You can use your forevers on the test, but this chapter, it's more of a skill thing than it is a memorizing thing. Does that make sense, kind of? All right. Number 6, why are they saying find the particular? Because they give us a clue. Gotta get out our handy dandy notebook. But before we ever get to that, what do we actually have to do? Guys, check out the forever card. What's the first step whenever we're trying to solve a differential equation?
Solve by separation.
How? What do we separate first? The very first thing. I know the letters are different, but the idea is not. I have to split up what? What am I separating first? Yeah, the dy dx, or in this one, it's the dr ds. Before you do anything else, please, if you just make this a habit, oh my goodness. There are FRQs sometimes worth 4 to 5. I've seen it worth up to 8 out of 9 points of 1/6 of the free response section of an AP. They will give you none of them if you don't do this first. All the points gone if you don't do this first.
Even if you get it right.
Well, the odds of you getting it right are very slim if you don't do this first. But if you don't separate the variables, they say 0 out of 4, 0 out of 9, 0 out of
Or what if you get it
on the scoring guideline.
Wait,
Don't tell me what if. It's a national thing. Too bad, so sad.
not separate.
Go talk to all the people in the Hilton rooms in Florida. So we have 3 dr. Just kidding, they won't listen to you. Equals. Now, I have a ds. Do we see that we have an issue in the e? There's an r and there's an s. I can't take an integral if there's an r and an s. I need to split it up. Oh, Vaughn, your question was gorgeous. How do I split up? Like, the timing was perfect. Right? The timing was perfect. Because what happens if I have a minus?
Oh, negative.
E to the r can become, e to the r minus 4s can become e to the r over, right? Or times e to the negative 4s, which is 1 over e to the 4s. Oh my goodness, in calculus you get good at exponent rules from Algebra 1. Now we can go ahead and rearrange things just a bit. For instance, I can multiply my e to the 4s to the other side. I need it. Wait a minute. No, I want him to stay. Who do I need to leave? Yeah. So never mind. I'm going to move my e to the r to the other side. And I'm going to have 3. Now hold on. Why is she rewriting it with a negative? Because that's better for my rules. I want an e to the u. I don't want a 1 over e to the u. 1 over e to the u does not compute as a rule. Don't you dare go saying ln. Make it e to the negative, because then I'm like, I got it. As long as I don't forget all of last chapter. U sub. I gotta do my U sub. But if you want, technically we're going to have to call them by different letters. Because this guy says, sure, make me a u. And I'm like, okay, cool. And I have negative dr. I would multiply the negative on the other side. And I would end up with an integral of negative 3e to the u du, which would land me at negative 3e to the negative r, plus a c that's going to go on the other side, equals. But this guy, doesn't he need his own? In calculus, if we already use the u, we can always use a v if you want to be super accurate. Did Lucas pick a good question? I think he did.
I think so too.
But he also said he got up to number 6 after just a little bit of time that we were working in class today. That maybe is a little encouraging. And I'll end up with a negative 1/4 integral of e to the u, well, technically e to the v dv if I want to be super snazzy. Whatever, I can still integrate that, and I have negative 1/4 e to the negative 4s plus c. Question, does it say I have to get y by itself?
No.
Not necessarily, but I could simplify a few things if I wanted to, like e to the negative r is equal to, I don't know, there's different things we could do. Long story short, we gotta plug in our clue. We'll see if you guys are able to get there on your own when we come back together on Friday. Bye, guys. I think I would multiply both sides by a negative 4. That's totally what I would do.
Yeah.
Right? That would make life way better. I'm gonna do that right
You literally like sprain your leg going jumping for a ball before a game. Really? Literally, like she, mark my words, she showed off vision. Don't tell that to coach. How did you guys test it? Those just make me super worse.
I think